Hi guys, here's day 2 of section 1.4. We're talking about composition of functions and then using composition of functions to prove that two functions are indeed inverses. So let's first talk about what it means to be a composition of a function. We're going to start off just by simply evaluating these two functions. First, we want to find f of 1. And you already know this from Algebra 1. We're going to plug in 1 everywhere we see x. And 2 minus 5 would be negative 3. And then we want to find g of 8. Which means now we're using this function over here. Everywhere I see an x over here, I'm going to put an 8. So I've got 8 plus 4 divided by 2. 12 divided by 2 is 6. And then we want to find f of g of 6. All right, this is what is called a composition function. So we have to first find and take care of what's in the parentheses. So first, I want to find f of g of 6. So first, I'm going to find g of 6. That's x plus 4 divided by 2. Oh, sorry, not x plus 4, Ms. Harris. We're replacing x with 6. So 6 plus 4 divided by 2. 6 plus 4 is 10 divided by 2. So g of 6 is the same thing as 5. So now I'm going to take this 5 and I'm going to plug it in for g of 6 here. So instead of f of g of 6, I've got f of 5. And now I'm taking 5 and plugging it into f of x, just like I did up here with the 1, I'm now doing it with a 5. So 2 times 5 minus 5, sorry, wrong position. 2 times 5 minus 5, so now I've got my parentheses in the right place. 2 times 5 is 10 minus 5, so f of 5 is 5. So f of g of 6 is, in the end, 5. All right, going the other direction, this means I'm going to evaluate f of 5 first and then plug it into g. So g of f of 5. Well, we just said f of 5, if you forget everything in the middle, we said f of 5 equals 5. So I'm going to plug 5 in here for f of 5. And so now I'm plugging 5, not into f, but into g. So 5 plus 4 divided by 2, that's 9 divided by 2. You can leave it as a fraction, or you can say it's 9 halves. You could say it's 4.5. Either of those will work. All right. And then we're going to review what we just did yesterday. So yesterday we just found the inverses. That's what we're going to do here. So remember, the first thing is I take it out of function notation and I make this y is equal to x minus 6 divided by 4. My second step is I switch my x's and y's. So this is x is equal to y minus 6 divided by 4. And once I've switched my x's and my y's, I'm going to solve it for my new y. So I multiply times 4. Then I get 4x is equal to y minus 6. And then I want to add 6 to both sides to get rid of this negative 6. So I have y over here is equal to 4x plus 6. Once we have the new y by itself, don't forget, we've got to go back and put it into function notation. Normally, we would say f of negative 1, but here our function was h of x. So we've got to use the same notation as the original guy. So not f inverse of x, we want h inverse of x. Because this is the inverse of h of x. And that was 4x plus 6. All right, so that's a review of what we did on Monday. Now we are going to talk about what it was to be a composition function. So going back to what we did in the warm-up, a composition of functions is when you plug one function into another function. So it's the result of plugging one function into another function. So why do we really care about composition of functions? We actually use composition of functions to prove that two functions are inverses of each other. So let's see what that means. So for example number 1, it says use composition of functions to determine whether or not the two functions below are inverses of each other. They are only inverses of each other if f of g of x is equal to x and g of f of x is equal to x. So if you can prove that both of those equal x, then they're inverses of each other. If they're equal to anything but x, like x minus 5 or x squared plus 3, anything other than just plain old x, they're not inverses of each other. So let's first go with f of g of x. I am plugging g of x into my f function. This time I don't have a number, so I'm going to say what is g of x equal to? It's equal to this guy up here. So instead of f of g of x, I'm going to write f of what it's equal to, which is 1/2 x plus 2. All I did in that step was say, I'm not writing g of x, I'm going to write what it's equal to, which is 1/2 x plus 2. Then I need to evaluate f at this value here. So instead of having 2x minus 4, I've got 2 times everything that's in this parentheses, which is 1/2 x plus 2 minus 4. So f of x is 2 times x minus 4. This would be 2 times x minus 4, but I'm evaluating it here, so that's what gets plugged in for x. Once we get everything plugged in, it's just a simple math problem. So 2 times 1/2 is 1, so I got 1 times x, which is x. 2 times 2 is 4, and then minus 4. This plus 4 minus 4 cancel each other out, and that's equal to x, which is what I needed, right? So I've satisfied this part. Now I've got to go prove that it works in the other direction as well. You can't do just one direction, it has to be both. So now I want to find g of f of x, which means I am plugging f of x, which is 2x minus 4, into my g of x equation. So I'm plugging this guy here into g of x right there where I see the x. So it'd be 1/2, not times x, but times 2x minus 4. And then I've got the plus 2. Let's go ahead and distribute. Once you get it plugged in, it all just works out to a simple Algebra 1 problem. 1/2 times 2 is 1, so this would be 1x. 1/2 times negative 4, that's the same thing as negative 4 divided by 2, which is negative 2. And then the plus 2 drops down. Negative 2 plus 2 goes away, so I just have x. So now I've proved it in the other direction. Again, if you can show that f of g of x is equal to x, and g of f of x is also equal to x, these two are inverses. Not that they have inverses, but they are the actual inverses of each other. All right, let's look at the next example. Now f of x is 4x minus 10, g of x is x minus 5 divided by 4. It says use composition of functions to determine whether or not these two are inverses of each other. So remember, first direction, I'm going to do it all in one color this time. F of g of x, which means I'm taking this guy and plugging it in. So f of x minus 5 divided by 4. That means I'm plugging it in for x into here. So that'd be 4 times, not x, but x minus 5 divided by 4 minus 10. When we multiply this out, 4 divided by 4 would just be 1. So this would be x minus 5 minus 10. Negative 5 minus 10 would be negative 15. So this guy does not equal x. Not equal to just plain old x, right? So these two functions are not inverses of each other. That's what you just proved. Now, if you get it to where it doesn't equal to x, you might want to go back and check your work. Sometimes we make some calculation errors, but in the end, if you get it to where it's not equal to just x, they're not inverses of each other. Let's look at the U try example. We have a typo here. There should be f of x and g of x, or f of x and h of x, or something. But they both can't be f of x. All right, so we got f of g of x. G of x is x plus 5 divided by 2. So I want f of x plus 5 divided by 2. So this means I've got 2 times x, but x is x plus 5 divided by 2, and then minus 5. When we multiply this out, the 2's cancel, and I get x plus 5 minus 5. So x plus 5, and then minus the 5, and then 5 minus 5 is 0, so this is just x. Going in the other direction, I've got g of f of x. So that is g of 2x minus 5. So instead of having x plus 5 up here, I've got 2x minus 5, and then plus 5, all over 2. All right, minus 5 plus 5 cancels each other out, so I've got 2x divided by 2. Here the 2's cancel each other out, and I've got x. So since we've equaled x both going both directions, these two are inverses of each other. All right, example number 3. Determine the inverse of the following function, then use composition of functions to verify your answer. So first, we have to figure out what is the inverse, and then figure out if it is, or check that it is the inverse by using composition of functions. I'm going to hold off and not make one giant video. I'm going to make 2 videos out of this. So come back and I'll do example 3 and 4 in the next video.